Taking a look at the switch configuration components, we need to be concerned with security as well. What do we do with the switch to better protect it? What if our ports are on and no one's plugged in? Could someone walk by and actually plug into a port on the wall? So we need to make sure that we protect our switch somewhat. We talk about getting into the devices from out-of-band management and in-band management. In-band would be Telnet. Maybe we want to set up SSH. That would be the appropriate thing to do. Best practice today would be to secure any unused port, and anytime you want to connect up to your device, to use SSH to do that. Let's take a look at the configuration. So we'll take a look here at switch 1. Whoop, kind of a funky arrow, but we got the idea here. We'll take a look at switch 1 as far as its configuration. We have 3 used ports, FA01, FA02, and FA03. It's a 24-port switch, so all the other ports are not being used right now. If these were actually connected out to a wall jack someplace and some contractor came walking through and plugged into the wall, they could potentially get a connection to the switch. And I don't know that they could log into the domain, but they would have some connectivity. So really what we'd like to do is make sure this device is actually secured to that respect. So what we'll do is we'll jump into the switch, take a look at the port status, get rid of this funky arrow that was drawn in here to start with, because we don't really need that anymore. Jump into the switch. And console in, C-O-N-S-O-L-E, enable Cisco is to get in here, do a show run, and if we look at the interfaces, we can see that all the interfaces are actually not shut down. They're enabled, they're running. So I'm connected to interface FA01, 02, and 03. Show IP int brief. Again, we can see that they're all running. We can see that ports 1, 2, and 3 are up and up. So I have something plugged into them. I may not necessarily know what they are from here. We could use something like Cisco CDP to find that. All I care about is I don't want to shut down a used interface. So 4 through 24 are not being used, so I should shut them down. Go into global config, interface, range, and again in my switch I can specify a range of addresses. FA0 /1, nope, not 1, 2, 3 are being used. Interface FA04 through 24. I'll be doing all of them at the same time, do a shutdown on them. Whoops, shut down. We should do down. And all those interfaces that go to state administratively down. If I go back and take a look at my running config, we can actually see that all the interfaces now have the word shut down there, except for interfaces 1, 2, and 3, because we have something connected to them. So we've effectively secured all those other interfaces. Now, if we go to the bottom of this configuration, we look at our VTY, we are set up for VTY, which is Telnet, with our password of Telnet, and we're logging in, meaning we're asking someone for a password. I really want to switch over to SSH. So in order to do SSH, we're still going to configure it under the line VTY parts. It's going to be there, but we're going to set up SSH to run instead. In order for SSH to run, I need a few different parameters. The parameters I need is I actually need a public key, private key pair. So I'm going to have to do a crypto key generate. Generate, that will create, generate, kind of a funky word there, but that's going to create my RSA key pairs. So I will have a public key and a private key, so that when I attempt to connect to this switch, by using SSH, knowing that we have a public key available, it will send the public key to me, and we can use that to establish our session. I will need to have a domain name set up as well. A domain name, our PKI, or our public key infrastructure, requires that the certificate have a name associated with it. So domain name is something we need to configure. We'll use example.com here. What else do we need? Well, we'll need to tell the VTY lines that we want our transport input to be SSH. By default, transport input is Telnet, and we don't see that in here because the default is not shown to us. We're going to change it to SSH so that we're not accepting Telnet anymore. Again, what does that really do for us? Telnet here uses port 23. SSH uses port 22. So effectively, by doing our transport input to SSH, we're telling the switch here to listen for port 22 instead of port 23. Now I can actually do both. I could actually have my transport input set up for SSH and Telnet, and the command is actually the same. I'll show you the command here. I'll type it in a second. Transport input Telnet SSH. That command would allow me to accept both Telnet and SSH. I'd be listening for port 22 and 23. But if we go back to talking security for a minute, if I'm switching over to SSH, because SSH is more secure, why would I ever let you Telnet back in? Telnet is not secure. Remember that Telnet is clear text. Everything that comes across the wire is clear text. So we don't like Telnet. So in fact, if you were to look at a security configuration and you saw transport input SSH Telnet, you would want to get rid of Telnet because that's a non-secure piece. You want to make sure that you are secure. So we're just going to do transport input SSH. We also want to log in locally. So we're going to create a username and password, because I need someone, if they're going to log in, to be able to specify their username and password when they log in. So this login here says just require a password. Password in this case is Telnet. I'm going to change that to login local. Login local means I'm going to be logging in with a local database defined on this machine, and that's where I'm going to define my username and password. Out in the real world or in a larger environment, we might actually use a AAA server. Authentication, authorization, accounting, Radius and TaxAct are both example of AAA servers. So rather than log in local, I might log in through a AAA server someplace. That would be more likely what you'd see in a medium or large environment. I don't want to create a database on every switch, every router I have of all the users that have access. I'd rather have one centralized database. But for us, we'll do our login local and we'll create the username and password right within this machine. And that's really all it takes to make it go up and run. I am going to change it to use SSH version 2. By default, it will be using version 1. Version 2 is more secure and it's fully supported. So we will set it up for version 2. So let's go in and actually set this up, take a look at it, see if we can make it work. I jump into my switch. Twice I had that little strange blurb show up there, but that's all right, we'll figure that out afterwards. So in my switch, I want to set up SSH. So I'll go into global configuration. The first thing I'm going to do is actually set my IP domain name. So I'll set my IP domain name, IP domain name to, that doesn't look right. Is that not right? No, it is. Domain name to example.com. And notice what I did there is I backed up a little bit and I put that question mark in. And so what does that question mark do for me? It shows me all the commands that start with the word domain. So domain is a valid command, domain-lookup is a command, and domain-name is a command. So again, if I'm thinking, geez, I'm not sure if I've got this right or not, I can always use my help functionality to make sure that I'm typing a valid command. I've just set my IP domain name to example.com. I also want to generate my key pair. I need to generate the public key, private key pair. So I'm going to do crypto key generate. And I'm going to generate an RSA key pair, which is the public key, private key infrastructure that we typically use today. Diffie-Hellman would be another choice. How many bits do we want to use? 512 would be less than standard. At least 1024 would be good for me. So I use a 1024 modulus here, that's what they call it, which is my key length. And my key pairs are now generated and they're available for me to use. So I have a public key, private key pair. SSH will grab a hold of the public key and send it down to any client that's trying to communicate with me so we can establish our secure communication. I also need to create that username and password. So username, we should do username, we'll do admin. And we'll do password, well, we want it to be secret, we want it to be encrypted. Secret will be Cisco. And that configures, that does all my global configuration pieces that I need. I just need to tell my telnet lines to accept SSH. I'm going to a little bit anal here, but I'm going to do a do show run because I want to make sure that everything is configured the way that I want it. I know that it is, I just typed it, but again, I have to verify it with my own eyes. So when I look at my configuration, there's my IP domain name, example.com. Here's my username admin with my secret MD5 hash password. Can't see what it is, but we'll assume that I spelled Cisco correctly, and that's good for me. When I go down and look at my telnet lines, I have nothing in here that tells me what I'm doing. I'm going to actually configure all 16 lines. So let's put the configuration in for VTY or telnet or SSH in this case. Switch to line configuration mode for VTY 0 through 15, which is all 16 lines. And I'm going to specify that my transport input needs to be SSH. I would like to specify that I'm going to log in locally. And that's really all I need to do. Ooh, I didn't change my SSH version to 2. So I should change my IP SSH version to 2 to be more secure, because it will still default to 1 for legacy configuration components. And that should take care of it. Do show run. I go down to my VTY configuration, and sure enough, it actually split it up for me. But I have login local, transport input SSH, transport input SSH. I still have a password telnet, but that will not work anymore because I'm doing login local. So this password has no meaning whatsoever. You cannot log in with the telnet password anymore. You're going to log in as a user, and you have to use that user's password, whatever this is. And that's the full setup for SSH. Can we take a look at it? Sure, I don't see why not. Let's try the PC and see if the PC can do it for me. Within Packet Tracer, I do have a telnet SSH client here, which should work for me. SSH to the name of the machine. What did we give that switch? IP address 192.168.10.9, if I remember correctly. And my username is admin. So when I connect, password was Cisco, and I'm into switch 1. So now I have a secure communication to my switch. I'm not using telnet, I'm using SSH, and I've done it from an SSH client. A lot of times you can do it from the command line as well. Either way, I have a command line interface. I'm now managing my switch in band using a secure shell protocol.